So this thing I use to help demonstrate the idea of coordinate direction angles. How a force can be 60 degrees to the x-axis and the component of the force in the direction of the x-axis, and also be 60 degrees to the y-axis and the component of the force in the y direction. So the idea of these coordinate direction angles can be confusing to some students, but I found this trick works pretty well. So you can replicate this visual aid using a piece of paper, a pen or a pencil. Sometimes I use a pair of scissors depending on what I'm working with, and a compass, and some triangles will also be helpful, but you can work with just a compass, a pencil, and a piece of paper. All right, so first thing I want to do is indicate a location on roughly the middle of the paper. Okay. And from there, this side of my paper is my x-axis. So kind of slid off the side there, but the bottom of the right-hand side of that mark, that's my x-axis. Now lining up with that axis and starting at my center point, I'm going to identify that 60-degree angle. So for cosine alpha, or alpha being my coordinate direction angle, or theta x, if I had 60 degrees, right, I'm going to indicate there. And I will go ahead and draw my force going out at that 60-degree angle. So this is my force vector. And this is that 60-degree angle. To demonstrate how much of F is projected onto X, right, I can use my triangle and drop that projection line down. That's a right triangle in there. And this piece along the bottom edge, this is the force in the x direction. Right? So cosine 60 degrees is going to equal f of x over f for my right triangle. Okay. Now, we're going to do the same thing for the y direction, but we already have the f vector. So now for our 60-degree angle from the f vector to the y-axis, we're going to mark off that 60-degree angle again from the same origin. Okay. We're going to draw that axis going out the other way. Right, so this is just my y-axis. Right, and again, this is a 60-degree angle. Now, this may start looking very odd to you with the x over here to the right and y going out to the side. Clearly, that's not traditional, but we'll see why this works. I'm going to drop that perpendicular, that projection of the force onto the y-axis. All right, and with this right triangle here, the projection of the force down here onto the y-axis, this ends up being right here. Right, this is the force in the y direction. And again, the cosine of 60 is going to equal the force in the y direction the adjacent over the hypotenuse, the force. So vector F, 60 degrees, cosine is alpha or theta x, giving us the x component. F with 60 degrees to the y, or beta, equal to 60 degrees. So we've included both of those coordinate direction angles, but again, the x and the y here look really awkward. So what we're going to do is fold directly on that force vector. And after we fold on that force angle, I want to take the x and the y axes and I want to make them 90 degrees apart. Okay, so you can see there how they're pretty much 90 degrees apart, but to force it, I could use, I can use that same triangle I've been working with. Let's go this way. And I can fold, I can actually even fold this side over, tape that down. Oh, and you know what? I'm out of my tape. Tape that down. Take this side, and I want to make the y-axis and the x-axis 90 degrees apart. So I rotate that over, tape that onto the triangle, and now those two axes are set 90 degrees apart like we know them to be. So there's x and y, 90 degrees apart, with the force coming up away from them. 60 degrees on this plane, 60 degrees on this plane. Now the z-axis is coming up towards you from that origin. And there's only one or really two angles that would still satisfy this situation. And I happen to have a 45-degree triangle here, and I can drop that down, and it fits right in between. Let's see here. Here. I can show it this way, kind of. Okay, so now the y-axis is coming out at you. The z-axis is down on the bottom, and the angle fits between the force and the z-axis. Okay, so that's a 45-degree angle. So with 60 degree alpha, 60 degree beta, 45 degrees is gamma. The other option was B if this was folded down and you had a negative 45 degrees or 135. So a piece of paper, a compass, a ruler or a triangle, and a pencil, and you've got a really good demonstration for what the coordinate direction angles mean. Alternately, on this one I did have a printout, and if you had something printed out that students could work with the 60 degrees, that would replace the need for a angle. So, hope that helps. Enjoy. Take care.